Hey everyone, and welcome back to AI Paper Podcast. Today we're taking a deep dive into a paper that's making waves in the world of multi-agent systems. We're talking about MAS-GPT, training LLMs to build LLM-based multi-agent systems, from the team at Shanghai Jiaotong University.
This paper is a fascinating exploration of how we can leverage the power of large language models, or LLMs, to design and build adaptable multi-agent systems on the fly.
So for those of you joining us for the first minute for the short edit, let's get right to the heart of it. Imagine this. You need a custom multi-agent system for a specific task, say analyzing your company's financial data or optimizing a complex logistics operation. Currently, building such a system is either a time-consuming manual process or requires multiple expensive calls to advanced LLMs.
It's a real bottleneck in the development of adaptable and efficient AI systems.
Exactly. Yeah. But what if you could simply describe your needs to an AI and it would design and build the perfect multi-agent system for you all within a single LLM inference? That's the game-changing potential of MAS-GPT.
MAS-GPT reframes the entire problem of building a multi-agent system as a generative language task. It's trained to take your query, say, analyze my company's financial data, and output a fully functional multi-agent system in the form of executable Python code. This means you can deploy the system immediately and get results without any manual intervention.
And here's the kicker. MAS-GPT doesn't just rehash existing designs. It can actually come up with completely novel multi-agent system architectures tailored to your specific needs. This opens up a world of possibilities for building highly specialized and adaptable AI systems for virtually any task.
And the implications are huge. We're talking about potentially democratizing access to sophisticated AI tools, allowing individuals and small teams to build and deploy complex systems that were previously only accessible to large organizations with significant resources.
It's really a paradigm shift in how we think about developing and deploying AI.
Yeah.
And for those of you sticking with us for the full deep dive, we're going to unpack this paper in detail, exploring how MAS-GPT works, its impressive results, and its potential impact across a range of industries.
So let's dive in.
All right, now that we've got the quick summary out of the way, let's take a step back and look at the current state of multi-agent systems. What are the main challenges researchers and developers are facing?
One of the biggest hurdles is this trade-off between adaptability and efficiency. You have systems like MetaGPT ChatDev and AgentVerse, which have demonstrated remarkable performance on specific tasks.
Yes, these systems are really impressive in their own right.
Absolutely. But they're manually designed, meaning each agent's role, its prompts, and how they interact are all predetermined.
So they lack the flexibility to adapt to different tasks or handle unexpected situations.
Exactly. You essentially need to re-engineer the entire system if you want it to do something new. It's like having a specialized tool that only works for one specific job. On the other hand, you have systems like GPT Swarm and Dylan, which aim for adaptability.
They allow the agents to dynamically adjust their behavior based on the task at hand.
Precisely. But to achieve this adaptability, they require multiple calls to large language models, which quickly becomes computationally expensive.
So you end up sacrificing efficiency for flexibility.
That's the dilemma. And it's a dilemma that MAS-GPT seeks to address.
Okay, so how does MAS-GPT break free from this adaptability efficiency trade-off? You mentioned earlier that it reframes the problem as a generative language task. Can you elaborate on that?
Sure. Think of it this way. Instead of trying to design the perfect multi-agent system for every possible scenario, what if we could teach an LLM to become a multi-agent system architect?
So instead of us humans designing the system, we let the LLM do the heavy lifting.
That's the idea. And that's where the generative language aspect comes in. We train the LLM to take a natural language query as input, which describes the task we want to accomplish, and output a fully functional multi-agent system as executable code.
Okay, now that's clever. So it's like giving the LLM a set of blueprints and asking it to construct a building based on those plans.
That's a great analogy. The query acts as the blueprint outlining the goals and constraints of the task, and the LLM, acting as the architect, generates the code that defines the structure and behavior of the multi-agent system.
But LLMs aren't exactly born knowing how to design multi-agent systems, right? How do you even begin to teach an LLM such a complex skill?
That's where the ingenuity of the researchers really shines through. They had to come up with a unique data construction pipeline to train MAS-GPT effectively.
Okay, let's break down this data construction pipeline. Where do they even start?
They begin with two key ingredients: a diverse pool of queries and a collection of manually designed multi-agent systems.
So they're starting with a set of problems and a set of solutions.
Exactly. The queries represent the types of tasks they want MAS-GPT to be able to handle, ranging from solving math problems and answering factual questions to generating creative text formats and even writing code. The manually designed multi-agent systems serve as examples of how different tasks can be decomposed and solved by a team of interacting agents.
It's like providing the LLM with a textbook of multi-agent system design principles.
Precisely. And the next step is to link these queries and multi-agent systems together.
How do they do that?
Well, they run each query through each multi-agent system and evaluate how well the system performs in answering the query.
So they're essentially testing which multi-agent system designs work best for which types of queries.
That's right. And this evaluation step is crucial because it provides the feedback the LLM needs to learn which designs are effective and which ones aren't. It's like giving the LLM a grade on its architectural designs.
I see. So the LLM starts to understand that certain multi-agent system structures are better suited for certain types of tasks.
Exactly. But they don't stop there. They go a step further by introducing the concept of consistency into their data pipeline.
Consistency, what do you mean by that?
Well, they identified two types of consistency: interconsistency and intraconsistency. Interconsistency means ensuring that similar queries are paired with similar high-performing multi-agent system designs.
So if two queries are asking for essentially the same thing, even if they're phrased differently, they should be paired with the same or very similar multi-agent system architecture.
Right. This helps the LLM learn generalizable patterns and avoid generating wildly different designs for queries that are semantically similar. Think of it like teaching MAS-GPT to be a chef. If you give it recipes for different types of pasta, it needs to understand that they share core similarities, even if the specific ingredients or cooking times vary slightly.
That's a great analogy. It helps to visualize how interconsistency guides the LLM's learning process. And what about intraconsistency?
Interconsistency focuses on the relationship between a specific query and its assigned multi-agent system. It involves refining the multi-agent system designed to be as relevant to the query as possible, and even providing a reasoning statement that explains why this particular design was chosen for this specific query.
So it's like providing the LLM with not just the answer key, but also a detailed explanation of the logic behind each answer.
Exactly. This helps the LLM develop a deeper understanding of why certain designs work for certain queries. It's like giving the LLM access to the architect's thought process, not just the final blueprint.
Yeah. This is a seriously impressive data construction pipeline. They're not just throwing data at the LLM. They're carefully crafting a curriculum to guide its understanding of multi-agent system design principles.
And all this effort pays off in the final stage: training.
Okay, so they've got this perfectly curated data set of query multi-agent system pairs. What do they do with it?
They use it to fine-tune a powerful open-source LLM called Qwen 2.5 Coder 32B Instruct, which is specifically designed for code generation and following instructions.
So they're taking an LLM that already has a strong foundation in understanding code and giving it a specialized education in multi-agent system design.
Exactly. They're leveraging the strengths of existing LLMs and tailoring them for this specific task.
And the result is MAS-GPT, an LLM that can take a query and output a ready-to-use custom-designed multi-agent system all within a single inference.
And the best part is that this generated multi-agent system can then be directly executed to process the original query and deliver a high-quality answer.
It's a beautifully streamlined process. It simplifies multi-agent system development while making it far more adaptable and cost-effective. This has the potential to be a game-changer.
It does. But the real test is in the results, right? Let's dive into the experiments and see how MAS-GPT actually performs in practice.
Do it.
The researchers put MAS-GPT through a battery of tests to really understand its capabilities. They tested it on a whopping 9 benchmarks covering a broad range of tasks, from math and coding challenges to general knowledge quizzes and even scientific reasoning problems.
That's a pretty comprehensive evaluation. And they didn't limit themselves to just one LLM either. They tested MAS-GPT using 5 different LLMs as the backbone for those generated multi-agent systems. So they were really looking at how well it generalizes across different models.
Exactly. They wanted to see if its success was tied to a specific LLM or if it was a more universal approach. And spoiler alert, their findings were incredibly impressive.
All right, spill the tea. How well did MAS-GPT actually perform?
Let's start with how it handled the variety of tasks. The researchers compared MAS-GPT to 10 other state-of-the-art multi-agent systems on 8 different benchmarks, and they used Llama 270B as the driver for the MAS. MAS-GPT blew them all out of the water. It achieved the highest average score across all the benchmarks. And here's the key. It wasn't just winning by a small margin. It demonstrated a significant performance advantage, showing that its approach is fundamentally more effective.
So it wasn't just a fluke. It was consistently outperforming the competition.
Absolutely. And remember, this was across a diverse range of tasks, some of which it hadn't specifically been trained on. So we see that adaptability and generalization we were talking about coming into play.
That's a huge win for real-world applications where you often encounter new and unexpected challenges.
Yeah.
We've got to talk about efficiency, too. Did they find that MAS-GPT delivered on its promise of being more cost-effective?
They did. In fact, this is where it really shines, because it only needs a single LLM inference to generate the entire multi-agent system. It's incredibly efficient compared to those other adaptable systems we discussed earlier, like Dylan and GPT Swarm, which require multiple LLM calls.
And as we all know, those LLM calls can add up quickly in terms of computational cost.
Exactly. So MAS-GPT is delivering both adaptability and efficiency, which is a pretty remarkable feat.
It sounds like they've really hit the sweet spot here. Now, they tested it with Llama 2. Did they try it with any other LLMs to see if the performance held up?
They did. They tested it with Qwen 2.572b and GPT-4 Mini as well. And the results were consistent across the board, top-notch performance, regardless of which LLM was used to power the generated multi-agent system.
Okay, so it's not dependent on a specific LLM. That makes it incredibly versatile. You're not locked into using one particular model to take advantage of this approach.
Exactly. It's very flexible in that sense. Now, they took their investigation a step further. They asked, could MAS-GPT actually enhance the performance of those already powerful reasoning LLMs?
Now, that's a fascinating question. We're talking about models specifically designed for complex reasoning tasks. It's like asking, can a team be smarter than its smartest individual?
Exactly. So they picked two of the most advanced reasoning LLMs out there, OpenAI's O1 Preview and DeepSeek R1. And they threw a really tough challenge at them, the MAS 2024 math benchmark, known for its complexity.
And this is where it gets really interesting, right? Because if MAS-GPT can improve the performance of these reasoning powerhouses, that's a big deal.
And that's precisely what they found. MAS-GPT provided a significant boost to both O1 Preview and DeepSeek R1. We're talking a 13.3% improvement for O1 Preview and a 10% improvement for DeepSeek R1. That's not a trivial difference.
That's a huge leap forward.
Yeah.
So even these highly specialized LMs, the ones at the top of their game, can benefit from the collaborative power of a well-designed multi-agent system.
It speaks of the fact that even the most advanced individual AI might have blind spots that can be overcome through teamwork and the integration of diverse perspectives.
It's like in basketball, even the most talented player can benefit from having a strong team around them.
Precisely. And to further test MAS-GPT's capabilities, they pitted it against a task-specific method, AFlow, a system that was specifically designed for optimizing multi-agent systems for solving math problems.
So they wanted to see how this general-purpose approach fared against a specialist in the field of mathematics.
They ran head-to-head tests on both in-domain and out-of-domain benchmarks. In-domain meant math problems. Out-of-domain encompassed tasks from other fields to assess generalization.
So a real test of flexibility and adaptability.
Exactly. And the results were quite telling. On the math problems, MAS-GPT actually outperformed AFlow, which is pretty remarkable considering AFlow was specifically designed for that task.
It's like a general practitioner outperforming a specialist in their own area of expertise.
It's a testament to the power of this general-purpose approach. And when it came to the out-of-domain tasks, AFlow struggled. It often performed worse than even a single LLM.
Whereas MAS-GPT continued to excel, demonstrating its adaptability across different domains.
Exactly. It really highlights the flexibility and broad applicability of MAS-GPT. You're not limited to one specific area.
Okay, so MAS-GPT sounds almost too good to be true. Did the researchers uncover any limitations or areas for improvement?
They did, and they were refreshingly transparent about the areas where MAS-GPT could be further enhanced. One key takeaway was the importance of data quality and diversity.
It's that old adage, garbage in, garbage out.
They found that as they scaled up the training data feeding the LLM, more examples of queries and multi-agent system designs, both the performance and robustness of MAS-GPT improved.
They noticed fewer errors and a higher success rate in generating executable MAS.
So more data, better results, which isn't surprising. It's like any learning process. The more you practice and the more varied your experiences, the better you become.
And they also hinted at the potential of using even larger LLMs as the foundation for MAS-GPT.
Because as we all know, in the world of LLMs, bigger is often better up to a point, of course.
Exactly. Larger models tend to have a greater capacity to understand complex relationships and patterns. So while they achieved these impressive results with the 32B model, they believe that scaling up to even larger models could unlock even more potential, leading to even more sophisticated and capable multi-agent systems.
It's definitely an avenue worth exploring, though. As you mentioned, it's essential to consider the computational costs and potential environmental impact of using such large models. It's all about finding that balance between performance and efficiency. Now, beyond the raw numbers and benchmarks, the researchers included some really interesting case studies in their paper.
Case studies are always helpful because they ground these abstract concepts in practical examples. They show how these systems can be applied to solve real-world problems.
Absolutely. And the case studies showcase some of the key strengths of MAS-GPT. They demonstrated its ability to generate unique, highly specialized multi-agent systems that are tailored to the nuances of a specific query, ensuring that the right agents with the right skills are assembled for the task at hand. They also showed how well MAS-GPT generalizes to new unseen types of queries, confirming that it's not just memorizing from its training data, it's actually learning how to design multi-agent systems from first principles. And perhaps the most impressive finding was its ability to design completely novel multi-agent system architecture structures that it had never encountered before. This means it's not limited to rehashing old designs. It can actually come up with innovative solutions, pushing the boundaries of what's possible in multi-agent system design.
Okay, so we've got performance efficiency, adaptability, and now creativity. Seems like MAS-GPT is checking all the boxes. It's moving us closer to that vision of AI as a true collaborative partner, augmenting human capabilities and enabling us to tackle increasingly complex challenges.
It's an exciting development, and it has the potential to transform a wide range of fields, from scientific research and software development to personalized education and creative industries.
And what's particularly encouraging is the researchers' decision to make MAS-GPT open source. This means the entire AI community can benefit from their work, building upon this foundation and exploring new applications and possibilities.
It's a fantastic example of collaboration and knowledge sharing in the AI community.
It's really inspiring to see this level of openness and a commitment to democratizing access to these powerful tools. And that brings us to the key question we always like to ask our listeners. What applications come to mind for you? How do you see MAS-GPT being used in your own work or in the broader world?
We'd love to hear your thoughts and ideas.
We've covered a lot of ground today exploring the world of multi-agent systems and the exciting advancements presented by MAS-GPT.
We've seen how it addresses the limitations of traditional approaches, offering a remarkable blend of adaptability, efficiency, and even a touch of creativity.
It really challenges us to rethink how we approach AI development, moving away from manually designing systems to empowering LLMs to become AI architects in their own right.
It's a paradigm shift that has the potential to unlock a wave of innovation, making sophisticated AI tools more accessible and easier to deploy across a wide range of industries.
And what's so inspiring is the open source nature of MAS-GPT. It embodies the spirit of collaboration and knowledge sharing that drives progress in the AI community.
It's an invitation for researchers and developers worldwide to build upon this foundation, to experiment, and to push the boundaries of what's possible.
And that brings us to the most exciting part, the potential applications of MAS-GPT. We've discussed its strengths and capabilities, but how do you envision it being used to solve real-world problems?
I think the possibilities are truly vast. Imagine a world where scientists can use MAS-GPT to design multi-agent systems that accelerate drug discovery or model complex climate patterns.
Or where software engineers can leverage it to build self-healing systems that automatically adapt to changing conditions or user needs.
We could even see it revolutionizing personalized education, creating adaptive learning environments that tailor content and pacing to each individual student.
And let's not forget the creative industry's MAS-GPT could be used to generate interactive narratives or design virtual worlds that respond dynamically to user input.
It's a future where AI becomes a true partner, augmenting our abilities and enabling us to tackle challenges that were previously considered insurmountable.
It's a future that MAS-GPT is helping to bring within reach.
Yeah.
And it's a future that I'm personally very excited to be a part of.
As am I. And we encourage all of you listening to join us on this journey. Explore the possibilities of MAS-GPT, experiment with it, share your findings, and let's collectively shape the future of AI.
Thank you for joining us on this deep dive into the world of multi-agent systems and the transformative potential of MAS-GPT. We hope you found it insightful and inspiring. And until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI.
Onwards and upwards.